Today's session that you're here to see is High Availability and Disaster Recovery 101 with Glenn Berry. And for those of you who are on the session and aren't really plugged into the SQL community, you are in for quite a treat. Glenn is an amazing presenter and writer and all-around great data person. And then remember, at the end, let me get back to this slide, we are going to ask you to provide your feedback and let us know what you thought about today's event. So don't forget that. So Glenn, if you'll give me just a second, I'm going to turn this over to you.
Okay.
Oh, Glenn, I forgot to ask. So do you have natural breaks built in for questions? Do you want me to hold them to the end? How do you want to do this?
I prefer holding to the end, actually.
Okay, we will do that. I'll just try to make note of where you were in the session when the question popped up.
Okay, can you see my screen?
I can.
All right, good. All right, so this is High Availability Disaster Recovery 101. I'm Glenn Berry. I've got a company called Dr. DMV LLC, and this is my Yay Me slide. The important thing about this is just my contact information. I'm pretty active on Twitter, Glenn Allen Berry, and my email is glennallenberry@gmail.com. And if you have questions that I don't answer or you don't think of during the session, go ahead and reach out to me. And I know how to brew beer. I'm fairly serious about it as a hobby. That's my 3-vessel brewing cart that I do all grain batches. I make 5 gallons at a time. And that's what some of my beer looks like. And I enter quite a few contests, so that stuff is on hold right now, unfortunately, but I've been lucky enough to win a few times. So I'm fairly serious about it. It's a really fun hobby. So anyways, let's get on to the business of the session here. We're going to be talking about why do you have downtime and data loss with SQL Server, and talk about how you go about planning an HA strategy. And I'm going to run through the technologies that are built into SQL Server 2019 to help you handle this, and then talk about how to plan a disaster recovery strategy and talk a little bit about disaster recovery methods for SQL Server. So that's a lot to cover in a fairly short session. So what does HA actually mean? Well, it means that something is able to be used as expected, despite things that might happen to try to prevent that from happening. So in our context, usually that means a back-end database that maybe is behind a web server or an application server. It's available, so you're not down. You can service transactions and everything's running as it should. And high availability means that whatever the something is you're trying to protect is protected by various different technologies and methods that we have available. And so there's lots of different somethings we might be talking about here. So it could just be a single table in a database, and that's fairly rare, but if that were the case, you might be able to use transactional replication to protect that table. But what's more common is either one or a group of databases you're concerned about, and you want to make sure that those are available. And there's different ways to try to make that happen. So for example, you could use an availability group in SQL Server 2012 or newer. Another example is maybe we're trying to protect an entire server or just an instance of SQL Server on that server. So then you might use something called failover clustering to protect an instance of SQL Server. And then you might be trying to protect an entire data center in case you have a flood or Grant's asteroid hits. So you might use something like SAN replication to replicate your data to another data center, or you might use something like log shipping to send the data to another location. There's lots of different options. So that's some of the different things you're trying to protect with high availability. Now, for downtime and data loss, there's 2 main categories of downtime and data loss. There's planned downtime that you schedule in advance, and then there's unplanned downtime that just happens because something that you didn't think about happened to you, and now you've got to deal with it. So you're trying to make sure you minimize both of those. Now, common reasons for planned downtime are things like doing database maintenance. So maybe you're going in and creating an index on a very large table, and you only have SQL Server Standard Edition, and it can't do online index operations. So you might choose to take a short planned outage to create an index on this huge table, because otherwise it's going to lock the table when you're creating the index, and you're going to have an outage anyways. Now, Enterprise Edition has online index operations, and that'll prevent you having to do that. And that's one of the reasons a lot of organizations will spring for Enterprise Edition, just for that one feature. But another thing you can think about to have planned downtime is a large batch operation. So maybe you've got to delete hundreds of millions of rows from a table. And the quickest way to do it is in a batch operation, but that's going to lock the table also. So if you go through and nibble at it, you can do it without taking an outage. But that's another common reason to take a planned outage. But probably the most common reason is doing things like installing a SQL Server service pack or a cumulative update, or updating your BIOS on your server, or updating drivers, things of that nature, or Microsoft updates. And you should, in my opinion, do that sort of thing on a regular basis. A lot of people are afraid to touch their servers. They never patch them, they never update anything, and then they have more problems. And this is especially important with cumulative updates for SQL Server. So those are probably the most common reasons for planned downtime. And if you do have an HA architecture in place, you can take advantage of that to minimize your downtime when you're doing patching, for example. So you can do what's called a rolling upgrade, where you patch one side of your HA topology and then you fail over and patch the other side. And that's very common and just a benefit you get from having that HA in place. So common reasons for unplanned downtime: you might lose your entire data center. So if you've got massive flooding or a big fire or power loss, things of that nature, you could lose your entire data center. And you need to think about, where do I live in the country or the world? What's the most common thing that might happen where I live? Are you, subject to earthquakes or flooding or hurricanes? And if that's a real consideration, you might want to have a second data center just in case you do get that hurricane coming into Florida, for example. A more common thing for most people is losing an entire server. Although PC-based hardware has gotten a lot more reliable than it used to be, you will occasionally lose an entire server because something just goes wrong. A power supply goes down or a CPU fails. That doesn't happen very often, to be honest, but that's something you might want to protect against. A more common reason is something goes wrong with your I/O subsystem. So you have a drive failure or a RAID controller failure, or there's a bug in your I/O subsystem somewhere with an old driver. And that happens more often than the first two. But by far the most common thing that happens, unfortunately, is human error. So somebody just makes a split-second mistake. And if you're a developer writing code, you can have all sorts of mistakes, and nobody usually sees that until you check your code in. But if you're a production DBA and you make a little tiny mistake, you think you were connected to development and you're actually connected to production, and you drop a table and your blood runs cold. Oh, what did I just do? Well, that happens a lot, unfortunately. And so that's what you need to think about protecting against to try to avoid unplanned downtime. So planning an HA strategy, a lot of people just think, okay, well, I'm going to go out and use availability groups. And they actually say always on availability groups, the marketing term. And that upsets some people in the SQL Server community when you say it that way. And that's not the right way to think about it. You need to think about what your recovery point objective is, RPO, and your recovery time objective, RTO. You need to go and talk to the business about this. Don't just assume that it's 10 minutes or 15 minutes. And if you don't talk to the business about it, the business is going to think that your RPO is 0 and your RTO is like 5 minutes. So no matter what happens, you can come back in 5 minutes. But it's important that you understand what RPO means, recovery point objective, and what it means in plain English. It's the maximum allowable data loss in terms of time when different kinds of failures happen. So that means you could at most lose, say, 10 minutes worth of data. And you need to come to an agreement and have the business sign off on this so that they don't think that it's 0 when it's really 8 hours or 24 hours. This is critically important. And this needs to be decided before you pick an HA technology. And then the same thing for recovery time objective. That basically means when something bad happens, like we lose our entire data center or we drop a table in production, how long does it actually take to recover from that? And you need to look at what you can do now and actually test it and then figure out, okay, here's what I can do, and figure out, is that good enough for the business or not, and come to an agreement so it's not being made up on the fly. And so another thing you need to think about is, does this mean, counting planned downtime versus unplanned downtime? And some organizations will talk about 3 nines availability or 4 nines availability. So that's something else to think about here. So here's a chart that talks about the allowable downtime you have per year and per month and per week with different levels of availability. So if you talk about 2 nines availability, that means 99% available. And that's pretty easy to do. That means you can have 3.65 days per year that you're down. And that's fairly easy. But when you go to 3 nines and 4 nines, it gets increasingly difficult to do that. 4 nines means less than an hour per year. And you can probably do that with a decent HA topology in place. So if you go to 5 nines, that's 5 minutes a year, and that's a lot harder to do. So this chart's kind of handy to understand how it gets more difficult as you increase the availability percentage. So SQL Server 2019 has a bunch of HA-related technologies. And the first 2 on this list aren't actually HA technologies. They're just things that you need to be doing and thinking about to make your infrastructure more robust. So we have backup and restore methods and component redundancy. And then the ones that are built either into Windows or SQL Server are Windows failover clustering, availability groups, database mirroring, transactional replication, and then log shipping and database snapshots. Those are kind of the highlights we're going to go over in this session. So the first one, backup and restore methods. The first thing you need to think about, and Grant did a great job talking about this, but you need to think about what recovery model are you using for your databases. And a lot of accidental DBAs don't even know what a recovery model is. They just create database, and then usually they're in full recovery model, and they don't realize that, and everything works great for 3 or 4 months until they run out of disk space because their transaction log grew and they had no more disk space. But most of the HA technologies you're probably going to end up using require you to use full recovery model. You can't use bulk logged or simple recovery model and have a lot of these HA technologies in place, unfortunately. So you need to make sure you know what recovery model you're using. Then you need to think about, what is my backup strategy in terms of when do I take full backups, when do I take differentials, how often do I take log backups? And that ties directly to what your RPO is you're trying to meet, because worst case scenario, if you can't take a tail of the log backup, you're going to lose everything since the last log backup. So if you're trying to meet, say, a 15-minute RPO that you agreed on with a business, you can't be taking log backups once an hour, because unless you get really lucky, you might lose the last hour's worth of data since the last transaction log backup. And differential backups are really useful, but a lot of organizations don't use them, sometimes for good reasons. If your data is really, really volatile, differential backups are very expensive and take up a lot of disk space. But having them helps you recover a lot more quickly by skipping a lot of transaction log backups. And then you need to think about, does backup compression work for me? And then I should be using backup checksums, definitely. And then use the backup tuning options you have inside of the backup command to make your backups actually run faster. And then you need to have a recovery strategy. A lot of organizations think about backups, but not about recovery. And like Grant said in his session, you actually have to test restoring your backup and know that you have a plan for how to do it, because that's the only way to really know for sure that your backup is good, is by restoring it. And a lot of people take backups and then they have an emergency and they find out their backups are no good, and then it's game over. And so instant file initialization and backup compression can both help reduce your restore times. And then keeping your VLF counts, your virtual log file counts, lower can really help reduce your recovery time. So if you've ever watched a backup go through and restore actually, and it says 99% done, and then it keeps on grinding for another 10 minutes, that's because you had a lot of VLFs and it was going through the recovery portion of the restore, and it takes a lot longer. So if you keep your VLF counts down, that won't happen to you. All right, so here's the backup tuning options I mentioned. You can use buffer count and block size and max transfer size. Those are optional parameters in your backup database command. And it's going to vary based on your data and your infrastructure, but it can have a huge effect and make your backups run a lot faster if you set these correctly. So it's something you should play around with on your larger databases to make this go more quickly. And then another thing you should do, in my opinion, is have what I call a secondary restore server, where you restore your production backups to that server on a regular basis in an automated fashion to make sure that the backups are actually good. And then after you do that, you can run dbcc check db on the restored backup to figure out if there's a problem there. And if you find it there, then you can run it again in production. But a lot of people are afraid to use dbcc check db on production because they're afraid of the resource usage. So this is a way to sort of get around that a little bit. So I've got a number of clients that do that, and it works really well. So the next thing to think about is a component redundancy. You want to have redundant components for a database server. It's not the same as a file server or a web server. And if you avoid having to go down or fail over because you lost a single hard drive or SSD, that's really good for your HA statistics. And it's not that expensive to do this. You're usually going to get pushback from people in your organization. Oh, we don't want to spend $500 extra to have a dual power supply, for example. And so you want to do whatever you can at the hardware level to eliminate single points of failure. So you want to have multiple power supplies plugged into separate circuits. You want to have multiple network ports plugged into separate switches if possible. You want to have an appropriate level of RAID. So RAID 10, for example, is more robust than RAID 5 for all your logical drives. And then make sure you've got hot swappable components. You know, tower servers, for example, usually don't have hot swappable components where rack mount servers do. And then you might want to have some cold spares available. So if you use all of a certain model of server, you might have an extra power supply or a couple of extra SSDs just in the cage with the server. So if one fails, you can immediately replace it and then worry about RMAing that failed one from your server vendor. So component redundancy versus HADR. All the HADR technologies we're going to talk about have some failover duration. So traditional failover clusters, you have to move the cluster resources to the other node and then start SQL up on that other node. That usually takes 30, 60, 90 seconds. So you're going to be down when you're failing over. Availability groups and database mirroring, they have a shorter failover duration, but it still is going to be some time. And then log shipping requires a manual failover, although you can automate that a little bit with scripts. So if you can avoid an unplanned failover because you lost a hard drive, that's a really good thing to try to do with your database server. So again, you just want to take advantage of anything you can for your mission critical database servers to make them more robust at the server level. But again, you're going to get pushback usually from your financial people about, oh no, we shouldn't spend that money. But think about how much does it cost per minute to you to be down, or how much is your customers going to be angry at you and lose faith in your company if your website is down. All right, so the first technology we're going to talk about is probably the oldest one, and it's Windows failover clustering. And this is a Windows failover cluster on a minimum of 2 machines, and you create the Windows cluster first, and then you install SQL Server in a clustered mode. And so you have, typically to start with, you've got 2 machines, and you install 1 instance of SQL Server. And this used to be, in the old days, be called active passive clustering, but some people get very upset if you call it that nowadays. But you have 1 instance, and it's running on 1 node at a time, and the other node is just sitting there doing nothing. And this lets you protect the entire instance of SQL Server, and then you can fail over back and forth between the 2 machines. And this requires shared storage, which is a single point of failure. And usually the shared storage is a SAN. And of course, the SAN vendors will tell you, oh, the SAN would never fail. It's got quadruple redundancy. It never fails, but don't believe that. SANs do fail. And so there's other ways to get shared storage. You can use SMB file shares, you can use Storage Spaces Direct, you can use third-party products to get shared storage. So you have to have that. But the nice thing about failover clustering is it gives you instance level HA. And this is great for novice DBAs or groups of DBAs that don't have that much experience with HA, because once you get it set up, it's really easy to administer. It protects all your databases and all your server level objects automatically. And as you add more things or make changes, it's just there. with a lot of these other technologies, when you do things like add logins or add new databases, you have to do work to protect them with your HA strategy. And this just takes care of it. So that's pretty nice. One downside of this is the failover takes longer. So it might take 60 seconds or 90 seconds to fail over. Because again, you've got to move the cluster resources and start SQL Server on the new node, and that takes some time. And keeping your VLF counts under control really can help with this, because when you start SQL Server, all the databases have to go through crash recovery, and that can take a long time when you have a lot of VLFs in each of your databases. All right, so something you can think about doing if you are using failover clustering is moving TempDB off of the individual nodes, or I take that back, move TempDB off of the shared storage onto the individual nodes. And quite often when you're using a SAN, especially if it's using magnetic drives, your TempDB performance might not be good enough for your workload because it's on the SAN. And if you can move it to your individual nodes, which is supported on SQL Server 2012 and newer, that usually gives you much better TempDB performance, especially if you move it to really fast local storage. And be prepared for pushback. Your infrastructure people won't like this idea one bit in many cases. But if performance is important to you, keep on fighting that fight. And you want really fast PCIe, NVMe storage, flash storage, and actually you want Optane storage, which is even faster than flash storage. So I'm going to go into my little Intel commercial for a second here. But Intel Optane DC storage, it's different than Optane memory or persistent memory you might have heard of, but it's 3D crosspoint based storage, which is not NAND flash. It's actually using phase change memory. And it's been around for about 3 to 4 years now. And I've had a lot of clients use this with incredible results if you have a really heavy TempDB workload. And it's just an expansion card that comes in different capacities, and it's not that expensive. And the nice thing about it, it works with all versions and all editions of SQL Server. It's completely independent of SQL Server, but just gives you much lower latency, better durability, better write performance. It's much, much better than any flash storage. And so it works great for very heavy TempDB workloads. And here's what it looks like. So that's enough of my Intel commercial. I don't work for Intel, but this is a great product. So anyways, the next thing I want to talk about is availability groups. So an availability group is one or more databases that fail over together. And this was added to the product in SQL Server 2012. And each new version of SQL Server has enhanced this and made it better. So it works really well in SQL Server 2017 and newer. And you have to have the failover cluster feature up until, I believe, 2019, but you don't have to have shared storage. And this was an Enterprise Edition only feature until SQL Server 2016. And then they added it in a slightly different version in SQL Server 2016 for Standard Edition. And all your databases have to be in full recovery model at all times to use availability groups. And an availability database is just a database that's in an availability group. And it's very common to have several databases on a server that maybe are used by a particular application. And you want to make sure they fail over together. So that's what availability groups let you do. And you've got the primary database on your primary node is your read-write copy, and you only get one of those. And then you can have multiple read-only or non-readable copies on other instances of SQL Server on different machines. And that gives you your HA story. And you can have up to 4 replicas in 2012, and then they've added more, so now it's up to 8 replicas. It's very uncommon to have that many replicas. And you can offload some read activity to those secondaries, but it doesn't really work that well in real life, unfortunately. So it makes it harder to use as a replacement for transactional replication for reporting. So basic availability groups is a new feature they added in 2016 Standard Edition that is meant to let you use that instead of database mirroring for Standard Edition. And it lets you have one database with one replica. You don't get multiple copies, and you can't read from the replica. And if you have, say, 10 databases, you have to create 10 basic availability groups. They can't all be in one like you can with Enterprise Edition. So it's basically very, very similar to database mirroring. And one big advantage of this over database mirroring is you can have asynchronous or synchronous for your replica. And with database mirroring in standard edition, you can only do synchronous, which can be a problem in some cases. So if you are going to be stuck on standard edition, you do have this option available for you because database mirroring is actually deprecated. It still works just fine. Microsoft was threatening to rip it out of the product in SQL Server 2017, but they chickened out at the last minute. So they're probably never going to take it out of the product, and it still works great. All right, so that leads me to database mirroring. So database mirroring was introduced all the way back in SQL Server 2005. And this is another database level HA technology. And like I said, it was deprecated in SQL Server 2012, which means that you're not supposed to use it for new installations or new development, but it still works the same way. There's no kill switch or timer. You know, if you use it in SQL Server 2019, it'll still work 10 years from now. So if it makes sense for you, go ahead and use it. And you have a principal database on one instance, and then you have a mirror database on another instance, and it doesn't require shared storage, doesn't require any kind of Windows clustering, so it's easier for some people to set up, and it's been around longer, so more people know how to use it. And you can use synchronous or asynchronous mirroring, and you can have a witness instance that lets you get automatic failover with synchronous mirroring, and so it's a fairly nice technology. It's been around a long time. Now, some of its limitations is, again, one database can be mirrored at a time. So if you've got 20 databases, you've got to go through and mirror each one of them, and then they fail over separately. Now, you can write some code like I've done in the past to make it so if one fails over, the other will go soon afterwards. And then the mirror is not accessible. You can't run queries against it unless you take a snapshot of the mirror, which is really not a good idea. So mirroring is another alternative. Another thing you can do is transactional replication. And a lot of people don't think of transactional replication as an HA technology, but it works for that. And some people will just go in and replicate the entire database. And then once you've done that, you can have multiple subscribers getting that data. And so it works as an HA technology. More often, I see it being used for reporting purposes. So you've got an OLTP database, and you're running queries against it for reporting, and that's causing performance issues. So you go in and turn on replication for certain tables and have them on a subscriber on a different instance of SQL Server, and then you can throw extra indexes on that subscriber and make your reporting queries run more quickly and not have that load on your OLTP main database. So replication basically means that you're picking up all the changes to the data and the schema on your publisher database, that's your read-write OLTP database, and then storing that in a distribution database for a short period, and then either pushing or pulling that data out of that to your subscriber databases that are running on other instances of SQL Server. And again, you can have multiple subscribers in different locations, and you can add those extra indexes if you want to, if that makes sense for your workload. And you can't do that with availability groups, by the way. So replication is not a dead technology. Microsoft added a lot of improvements to it in SQL Server 2017. And that's another thing. There's no more service packs in SQL Server 2017 and newer. And so with cumulative updates, Microsoft adds new features, not just bug fixes, but new features. So that's what they've been doing in some of the cumulative updates for SQL Server 2017. So some of these are replication enhancements that make it work better. So that's really nice if you are using replication. All right, another one that hardly anybody uses in my experience is called peer-to-peer replication. And this is enterprise edition only, but this is, again, database level protection. And the scenario for this is that, say you've got 3 different offices that are using SQL Server, and you want to make sure that the data is synchronized between all the offices, and you want to make all 3 copies of the database writable. And that's, a lot of people might ask for that. And so peer-to-peer replication is one way of making that happen. And it's just a form of transactional replication that lets you have multiple writable copies of the database. And they synchronize in a fairly short time if everything is running properly. Now, one problem with this, you might have to go in and make some application changes or database changes to actually do this, because, for example, if you're using identity columns in a table, and if you're not careful and don't reserve certain ranges of identity values for the different copies of the database, you're going to have collision. So you might have to make some changes for that, for example. And this is a little bit more difficult to set up and maintain. And like I say, hardly anybody in my experience actually uses it, but it is in the product. All right, another one that people tend to look down their nose at is log shipping. Log shipping's been around for a long time, and it's very, very simple. It's basically just automating your transaction log backups. And if you're in full recovery model, you have to take transaction log backups anyways. And this is another database level protection technology. And the nice thing about log shipping is that you can have multiple copies of your log ship database in multiple locations. Now, all your databases have to be in full recovery at all times, and you don't get automatic failover with log shipping, although if you're smart enough, you can write some code to semi-automate it. And then one downside of log shipping is that you can lose some data. It's more likely to lose data with log shipping because what happens with log shipping is you're taking a log backup on your primary server and then copying that somewhere else and then restoring it to its final destination. And depending on when a certain bad thing happens, you might not have gotten that last log backup from your primary server, or maybe it happened, but you can't get it. So you could lose everything since the last log backup that you got out of that server. So if you're taking log backups every hour versus every 5 minutes, that makes a big difference. Now, because of that, log shipping is usually used more for DR purposes rather than HA purposes, but it's better than nothing for HA. If you're a really small organization or you don't have experienced DBAs, log shipping is really easy to set up, and it doesn't put any extra load on your server like most of these other technologies do, because again, you're taking log backups anyways, so you might as well do that. All right, so database snapshots are another one that you can do. It was Enterprise Edition only until SQL Server 2016 SP1, and this just takes a point in time copy. It's not really a copy, but it's a snapshot that shows you what the data was like, and then it tracks the changes after that. And it's usually used for reporting or used to recover from a mistake that somebody makes. So if you're getting ready to push out new code to your database, you might take a snapshot, and then if the code messes everything up, you can revert back to the snapshot. That's a fairly common scenario. All right, HA features by edition. This chart's kind of handy because you've got Enterprise Edition, which has everything, and then you have Standard Edition, which doesn't have certain features. And then you have Express Edition, which hardly has any features, but it's 100% free. So there's certain things like partial database availability that's only in Enterprise Edition. So I'm not going to go through this entire chart, but some of the highlights are online index operations. That's Enterprise Edition only. Make sure you understand that, because that's a very, very valuable feature from an HA perspective and just from a day-to-day management perspective. So that's that chart. So now we're going to talk about planning a disaster recovery strategy. And it's really important that you go through and think about this and talk to the business and put together a strategy and answer as many questions that are going to come up during a disaster in advance, so you're not making it up on the fly. Because even with the most sophisticated HA technology in place, if you lose all of that, as long as you've got a SQL Server backup that you can restore from, you can eventually come back online. And I agree 100% with what Grant was saying in his session, that don't let anybody talk you out of not doing backups because you've got this particular appliance or this particular backup product. No, always do backups with SQL Server. And then if they want to take their fancy appliance or backup product and copy your backups somewhere else and deduplicate them or whatever the case may be, go ahead and do that and make sure you're doing native SQL Server backups. But anyways, some things you need to think about here is what needs to be brought online first. And in a disaster, if you don't have a plan, everybody's going to be fighting about, oh, my application is more important, or this database is more important. And the business is going to be fighting for attention. This should be settled in advance, so you're not just making it up as you go. And you need to think about your RPO, SLA you're trying to meet, and your downtime SLA, RTO you're trying to meet as you're thinking about this. So a good disaster recovery plan should be written by your most experienced people, but then tested by the junior people, because it's more likely they're going to be on duty at night or on a weekend or on a holiday. And you want to try to write it so a non-DBA could do it, because what if you're the only DBA in the company and you're not available when the disaster strikes? Can your sysadmin or some developer do it? And it needs to be very comprehensive and detailed. You can't just say, restore the database from backups, because unless you're a DBA working at your company, that's not going to be close to being good enough. So you need to have very detailed instructions. Okay, here's where the backups are stored, and here's our naming convention, and here's how you figure out what backups to restore in what order. And then maybe here's a sample script of how you would do it, and show them how to modify it. And then you need to have information in your DR plan about what if something goes wrong. You start the restore and it errors out immediately. What are you going to do? Call Glenn. Well, Glenn's not available. So have some troubleshooting steps for the most likely thing that might go wrong and how they can try to get past that in case Glenn isn't available. And you also need to think about the human factors. If you just had a hurricane hit and people's houses are destroyed, you think your employees are more worried about their family and their houses, or more worried about getting your website back up and running? You know, probably they're more worried about their family. It's just human nature. And so what some larger companies would do is if a hurricane's coming into Florida and they know it's coming, they'll put their key people and their families on a plane and fly them to their backup data center in Ohio and put them in a hotel. And then your employees can concentrate on their work and not worry about their family. So that's things you need to think about depending on where you're located in the world. And your DR plan needs to be tested. And every time you test and try to do practice DR, you're going to find holes and things you didn't think about. So you're going to update the plan, so the plan should get better over time. All right, so more things to think about from a DR perspective. What if the server is physically damaged? What would you do? Can you go to Micro Center and get a new server? Can you order one from Dell? How long would that take? What if the SAN is damaged? What would you do? What if there's no power at the data center? What if the data center is gone completely? Can you get additional servers somewhere? Could you use desktop machines temporarily? What if your first backup is corrupt? Do you have additional backups that you can try before you start updating your resume? What if your only DBA isn't available? Does anybody else have any clue about how to restore the backups? Things like this are important to think about. And then more people issues you need to think about. And really the people issues are the hardest part. But when something's going wrong, who do you have to notify that there's a problem? And who's responsible at each part of the recovery process? And you need to have hopefully somebody who's kind of a sponsor or stakeholder, somebody who has enough political power in the organization to settle disputes and be making decisions. And then as you're going through, who has to be kept informed of how you're going? Because you're going to get all these questions. How long till we're back up online? How long till we're back up online? How long is it going to take? And you know, this is important that you think about this. And then a key one, especially if you've got 2 data centers or even just any HA technology, who has to authorize a failover? And how long do you spend troubleshooting on your primary site before you fail over to the secondary site? And this needs to be thought about and agreed upon and written down in advance, because otherwise, if you spend an hour troubleshooting and you're down for an hour, the business might get very upset about that. Hey, we spent all this money on the secondary data center and you didn't fail over for an hour. Why did you wait so long? Or if you just fail over after 5 minutes and failing over causes all sorts of pain, you're going to get in trouble for failing over too quickly instead of troubleshooting. So somebody needs to think about who pulls the trigger and how long do you generally take before you fail over. You also need to make sure you've got contact information for everybody who's involved, not just the technical people, but some business people, because usually the technical people don't know the application 100%. They know the basics and they can do what I call smoke testing. But believe me, even after you fail over and everything looks like it's right, you'll probably hear from Sally in payroll who, oh no, something doesn't work and now we can't pay people. So you want to make sure you've got business subject matter experts who know how to test and make sure you're really 100% back up. All right, so HADR testing. You want to test your solution that you've built as much as you can before you go into production. And so not just the all typical things that you think would go wrong, but go and do other things that you don't think would go wrong. And so go and just pull out a drive or unplug a server or unplug a network cable and see what happens. Does it trigger a failover? Does the application just stay up? And what happens if you drop a table or truncate a table? So do things that hopefully wouldn't happen. And what we used to do when I worked at Avalara is we built a whole new HA architecture with 2 data centers, and we did everything we could think of to test it. And then we went and got a receptionist from the corporate headquarters and brought him over to the data center and said, okay, just go unplug something or flip a switch. And this person had no technical background whatsoever. And we uncovered a few things that we never thought of, because they, if you're the network expert, you're not going to unplug that one cable is going to kill everything. But the non-technical person won't have that, and you get better testing. Other things you might want to do is try doing a bare metal install or sending a new VM and see how long does that take. How long does it actually take to do a full restore of your biggest database from backup? If it takes 12 hours and you have an RTO of 4 hours, you're going to be in trouble. So you need to figure out what you can do to make it better, or go back to the business and say, hey, we just can't do it in 4 hours because it's so big and our infrastructure is not fast enough. So if it turns out you can't meet your SLA requirements that you agreed to when you were talking about all this, either push back on the business or come up with a better plan. And make sure that management knows what you can actually do before you go into production, so they're not unpleasantly surprised if you can't meet your SLAs. And then, this is hard, but you need to try to do it. Do some real life disaster testing in production. Some companies will do things like, just with no notice, come in and say, okay, you guys are down now, fail over to the other data center. And they'll see how long that takes and see how much mayhem ensues, whether that works or not. And that's really challenging to meet that. But if you've gone through that a couple of times, failing over will be second nature and nobody will be freaking out when it happens. All right, so just to start to summarize this, HADR is a lot more than just picking your favorite technology. I see people doing this all the time, where availability groups are the new shiny thing. They're not that new anymore, but they're the shiny thing from Microsoft. So a lot of people just say, we're going to use availability groups. And maybe that's not the best solution for your particular problem. And make sure you instead think about your RPO and RTO SLA you're trying to meet, and make sure you've talked with the business and settled on this instead of you just picking a number out of the air. And make sure they realize that the numbers are not going to be zero. It's really nearly impossible to guarantee 0 RPO and have almost instantaneous RTO. And of course, your RTO is going to vary based on what bad thing happened. If you have the asteroid hit your data center, your RTO is going to be a long time, no matter what. And then if the business is being completely unrealistic, maybe they want to have a secondary data center, but they only have a budget of $10,000. That's probably not very realistic. And quite often, if you go and talk to the business about, okay, we have this term called RPO, Recovery Point Objective, and that basically means how much data can you afford to lose before it's a problem. What are they going to say? They're going to say 0. We can't lose any data, or it'd be the end of the world. And what you need to do if they say that is say, okay, well, that's really difficult to come close to 0, but I tell you what, I'll put together a plan and a budget for how we can try to get as close to 0 as possible, and then we'll talk about it next week. So then usually if you do that and they see how difficult and how expensive it would be to have that, usually they'll back off and say, okay, wait a minute, we can't spend that kind of money, but maybe 5 minutes would be okay. So once you've come to that agreement, then you start to select your technologies and come up with your process to meet that. And then no matter what else, if you don't remember anything else from this presentation, make sure you've got a good backup restore strategy using SQL Server native backups, not some appliance, regardless of what else you do, because if everything else fails, as long as you can restore from your backups, you can come back up online. And that's super important. Don't let anybody talk you out of doing backups, no matter what. And I can't tell you how many times people have come to me at previous jobs and say, hey, the backups are taking too much disk space. They put too much load on the infrastructure. Let's not do that. Let's just do snapshots or use SAN snapshots or whatever, the cause of the day is. Don't let people talk you into do that. And then finally, make sure you understand that you can combine these things. So you can have availability group for your local HA, and then you can have log shipping for DR to another site. And something else you could do, you could have that same availability group for HA, and you can do log shipping with a delayed restore. So if somebody drops a table, you could go and get the copy where they hadn't done that from the log shipped and then restore that. And that might be quicker than restoring from a full backup just to get that one table back, for example. So there's things you can do to combine some of these technologies to cover everything you think might happen that's bad to your database. All right, so I've got some references here. Most of these ones on this slide are Pluralsight courses that I authored. So there's one on log shipping, how to set it up and configure it and monitor it. Another one for database mirroring. And then I've got one on how to install and configure SQL Server 2016. And it's very, very similar in 2017 and 2019. And then the final one is an old white paper from Microsoft. It's old, but it covers all the basic principles of HADR really, really well. And the only thing it doesn't talk about at all is availability groups because they weren't around back then. But all these other technologies are covered quite well in that white paper. And then that's pretty much it. If there's any questions, we have a little bit of time here. So hopefully you're all still awake and we have some questions.
Let me see. So when you were passing the availability group slide, we had a question from Cynthia Shoemaker. She says, how does SQL HA work in Azure? And I don't know if you have enough time for,
well,
for that.
You know, Azure has different things. You've got Azure SQL Database, which is a platform as a service, and then you've got Azure VMs, which is infrastructure as a service, and they do things differently. So if you're talking about Azure SQL Database, Microsoft takes care of all of that for you. They've got multiple copies of your databases that they take care of the HA. You just don't have to worry about it. If you're doing infrastructure as a service, you got to do something about it yourself, just like you would with on-premises SQL Server. And you can pick these different technologies and they work pretty much the same way in the cloud. Some things are a little bit more tricky, but generally speaking, they work the same way as on-premises.
And then you haven't mentioned strategies involving read-only file groups and/or partitioning. Any insights on combining these with the other strategies to reduce RTO? That's not a very 101 level question, but no. I'll let you answer that as best you can for everybody on the session.
Well, no, I don't really cover that. What I would say about that is I usually try to focus on doing what I can with the infrastructure and with some of the little things like using backup compression and using the backup tuning commands to make it so I don't have to worry about that sort of stuff. So, you know, if I've got fast enough storage, I can restore a multi-terabyte database in just a few minutes as opposed to hours and hours. So if I've got a very large database, I would tend to want to try to focus on the infrastructure personally because that's just my focus, hardware and storage, to make it faster and try to do things to reduce the need to have to use read-only file groups. So I guess that's my answer to that.
Okay, and let's see, we had one more pop up. Sorry, hold on. Oh, so are distributed availability groups a better way of reporting off of secondaries?
Oh, yes and no. I mean, my big, when SQL Server 2012 was coming out and they talked about availability groups, I was really excited because replication is going to be kind of a pain in the neck sometimes. It works really well most of the time, but it breaks fairly often, and it causes a lot of headaches to a production DBA. And so I was all excited that I wouldn't have to use replication for reporting because availability groups would let me do the readable secondaries and run the reports there. But the problem is you can't make any schema changes. So you can't add extra indexes. And if that's important to you for performance, then I don't care what kind of availability group you're talking about, you're going to have issues. I mean, they do some things with TempDB to try to have temporary statistics on the secondary, but it's not the same as an index for queries. So
yeah, we struggled with that very problem at the last company I was at. Was how do we tune this database? Do we, are we tuning it for the transactional side of it, or do you want us to tune it to produce reports?
right,
And
and
there was a lot of back and forth.
Yeah, if you add extra indexes to the OLTP one, then you're paying the price of maintaining them for your OLTP copy, and that can be painful.
Okay, that was the last question that we had for you today, unless any pop up in the next few seconds.
All right, well, thanks everybody for listening, and I'm gonna put a PDF copy of this deck up on my website, and then I think it's gonna be available on the main website for the event eventually, so.
So can you your website again is, just tell us.
Well, it's glensqlperformance.com. So
Okay.
if you just Google Glenn Berry SQL Server, you'll probably find it really easily.
I have Googled Glenn Berry SQL Server looking for a specific script that you have written many, many times in my career.
Yeah.
So there's a whole lot of stuff that comes back.
All right. Well, thanks everybody for listening, and thanks for moderating, Ree.
No problem. It's good to have you.